Welcome back. Let us continue. First question. The speed of a boat when traveling downstream is 32 km per hour, whereas when traveling upstream it is 28 km per hour. What is the speed of the boat in still water and speed of the stream? Speed of the boat in still water is nothing but u and speed of the stream is v. They are saying the speed of the boat when traveling downstream. Downstream is nothing but u plus v, that is 32 km per hour, and when traveling upstream it is 28 km per hour. Upstream is u minus v, which is 28 km per hour. So adding these two will give you 2u is equal to 60, u will be equal to 30. Substituting this into the first equation, we will get v is equal to 32 minus 30, that is v is equal to 2 km per hour. So the answer will be 30, 2. The answer is B. I hope you got the logic. They are saying the speed of the boat when traveling downstream is 32. That is the sum of the speed of boat plus speed of the stream, that is 32 km per hour. And whereas while traveling upstream it is 28 km per hour. That is the difference between speed of the boat and speed of the stream, that is 28 km per hour. So adding these two and subtracting these two will get the value of u and v. Okay, now we got the speed of the boat u and speed of the stream v. I hope this is clear. Next question. The ratio of speed of a motorboat to that of the current of water is 36:5. The boat goes along with the current in 5 hours 10 minutes. How much time will it take to come back? Okay, they are saying the ratio of the speed of the motorboat, that is u, and that of the current of water, that is v, is 36:5. It means u is equal to 36x, v is equal to 5x. Let us assume like this. The boat goes along the current in 5 hours 10 minutes. Along the current means downstream. So time taken downstream is equal to 5 hours 10 minutes. We shall write this as 10 by 60 in hours. This will be 5 1 by 6. This is 30 plus 1 31 by 6 hours. Okay. So time taken downstream is 31 by 6 hours. We shall find out the distance from this. The distance travelled will be equal to, this is in along the current. We shall write this as downstream. This will be equal to the speed downstream, that is u plus v into time taken downstream. U is 36x, v is 5x. So this will be 36 plus 5x into time taken downstream, 31 by 6 hours. Let this be 41x into 31 by 6. We shall rewrite this 41 into 31 by 6x. Let this be the distance downstream travelled. Okay, here we can see the distance is constant. That is either upstream or downstream, the value will be remaining same for distance. They are asking how much time will it take to come back. It means time taken in the upstream. The first one is going along the current, that is downstream. The second one is coming back, that is in upstream. Time taken upstream is equal to the distance travelled divided by the upstream velocity, that is u minus v. So we can substitute the value here. D is equal to 41 into 31x by 6. U minus v is 36x minus 5x. This will be equal to 41 into 31x divided by 6 into 31x. This will get cancelled. So the answer will be 41 by 6. So we shall calculate this. 5 6 are 30, 6 6 are 36. 5 0.50. So this will be 8. 8 6 are 48 and 20. We shall calculate this. We shall divide 41 by 6. So 6 6 are 36. So the balance will be 5. So the value will be 6 5 by 6 hours. So we can write 5 by 6 hours as 5 by 6 into 60, that is 50 minutes. This will be equal to 6 hours 15 minutes. So this is the time taken to travel upstream. The answer will be D, 5 hours 60 minutes. Next question. A man can row 6 km per hour in still water. It takes him twice as long to row as to row down the river. Find the rate of the stream. They are saying U is equal to 6 km. They are asking the rate of the stream, that is V. They are also saying it takes him twice as long to row up as to row down the river. It means time taken to row up is equal to 2 times time taken to row down. So from this we will be able to calculate. The distance is same in either case. So we shall substitute time taken upwards will be equal to the distance travelled divided by the upstream velocity U minus V. This will be equal to 2 into the distance travelled divided by downstream velocity U plus V. Okay, now we shall substitute the value of U in this equation. We can cancel D on either sides. 1 by 6 minus V is equal to 2 by 6 plus V. We shall reverse this. 6 minus V is equal to 6 plus V divided by 2. We can take 2 to the other side. 12 minus 2V is equal to 6 plus V. So 6 will be equal to 3V. V will be equal to 2. So the rate of the stream V is nothing but 2 km per hour. The answer is C. Okay. Next question. A man can row 7.5 km per hour in still water. So U is equal to 7 1 by 2 km per hour. If in a river running at 1.5 km an hour, then V is equal to 1.5 km per hour. It takes him 50 minutes to row to a place and back. How far is the place? He is saying it takes 50 minutes to row to a place and back. It means the total time taken is 50 minutes. That is time taken upstream plus time taken downstream is equal to 50 minutes. Since all the units are in kilometer and hour, I shall write this in hour. Okay. They are asking how far is the place. Time taken upstream is nothing but, I shall write this here. Time taken upstream is nothing but the distance travelled by relative velocity, that is U minus V. Time taken downwards is distance travelled by U plus V. We shall substitute this here. D by U minus V plus D by U plus V is equal to 5 by 6. U is equal to 7.5 and V is equal to 1.5. We shall substitute the values. 7.5 minus 1.5 is 6 plus D by 7.5 plus 1.5 is 9, which is equal to 5 by 6. Okay, D into 6 into 9, 9 plus 6 is equal to 5 by 6. We can cancel 6 on either sides. So D into 15 by 9 is equal to 5. This will be 3 times and this will be 3. So D is equal to 3 km. The answer is A, 3 km. Okay. Next question. A boat goes 8 km upstream and then returns. So the distance is 8 km. Total time taken is 4 hours 16 minutes. Time total. Let this be T0, which is 4 hours 16 minutes. If the velocity of the current is 1 km per hour, that is V is equal to 1 km per hour, find the actual velocity of the boat, that is the velocity in still water, that is U. They are asking to find the value of U. We shall solve this. The total time taken is T0, which can be written as time taken upstream plus time taken downstream. This is equal to 4 into, we shall divide this by 2, this will be 8, this will be 30, again by 2, 4, 15. This is equal to 4 into 4 by 15. This is 5 4, 15 4s are 60, 60 plus 4, 64 by 15. The time taken is 64 by 15 hours. So we shall write 64 by 15 hours. Time taken upstream is distance travelled by U minus V plus time taken downstream is distance travelled by U plus V, which is equal to 64 by 15. They are saying V is 1 km per hour. They are asking the actual velocity. D is given 8 km. 8 by U minus 1 plus 8 by U plus 1 is equal to 64 by 15. We shall cancel 8 throughout. This will be 1 by u minus 1 plus 1 by u plus 1 is equal to 8 by 15. We shall multiply this. This will be u minus 1 into u plus 1. Here the numerator it will be u plus 1 plus u minus 1 is equal to 8 by 15. This will get cancelled, plus 1 minus 1. 2u by u square minus 1 is equal to 8 by 15. We can take this to the other side. 30u is equal to 8u square minus 8. We shall rearrange this. 8u square minus 30u minus 8 is equal to 0. Let us try to solve this quadratic equation. 8 8s are 64. Here it is minus 64. Can be solved by 16 into 4. This will not be 30. Or 8 into 8 will not be 30. We can solve this by 32 into 2. So minus 32 into 2. So we can write this as 8u square minus 32u plus 2u minus 8 is equal to 0. We can take 8u outside. 8u into u minus 4 plus 2 into u minus 4 is equal to 0. So u minus 4 into 8u plus 2 is equal to 0. Okay, u cannot be negative. So u is equal to 4. This is not possible. So the actual velocity of the boat, that is u is equal to 4 km per hour. The answer is C. Okay, we shall finish the remaining problems in next lecture. Thank you.